Factoring a trinomial when a is not 1. The first step we do is always look for a GCF. Is there a common factor that goes into each of the numbers? There's not on this problem. Nothing goes into 6, 7, and 20 nicely other than 1. So then step 1 is to find AC, multiply. This is ax squared plus bx plus c. We multiply a times c. Let's see, 6 times 20 would be negative 120. All right, now we find factors of 120, negative 120, that are going to add up to 7. So we look for factors of AC that add to B. So factors of 120, obviously 1 times 120, but there's no way that's adding up to 7. In order for this to get 7, I imagine one of them is going to be negative and one of them will be positive. See, 2 times 60, but again, that's not going to get me 7. 3 times 40, getting closer. 4 times 30. Let's see, 5 will go into it. 24. And 6 times 20. Let's see, 8 will go into it. All right, let's see. 8 times 15. There it is. Okay, here's our numbers. And I know those are the numbers because 15 take away 8 is going to give me the 7. In order to get 7, the 15 would be positive, the 8 would be negative, and those will add up to 7. Then we draw our box. The first term always goes top left. The last term always goes bottom right. And our two factors go in the diagonal. It doesn't matter which one they go in, and they get the variable. One of them is negative 8x, the other one's 15x. Then we look for our GCF on the top row. Wow, I just wrote that. Let's see, do this with a highlighter. The top row, those have, let's see, 2x in common. On the bottom row, those are both divisible by 5. And then let's go vertically on the vertical row or vertical columns. These two are divisible by 3x. And these two are both divisible by negative 4. When you get to this stage, always double check to make sure the things on the outside multiply to give you what's on the inside. For example, when I do 3x times 2x, do I get 6x squared? I do. When I do 2x times negative 4, I get negative 8x. And 3x times 5 is 15x, and negative 4 times 5 is negative 20. It works. So since the stuff outside multiplies to give me the stuff inside, my factors are the factors on the top and on left sides, which are 2x plus 5 times 3x minus 4. All right, let's do another example. Here's another example where a is not 1. In this case, a is 6, b is negative 5, and c is 1. If there's no GCF, we do a times c, which is 6. I need two numbers that multiply to give me 6 that add up to negative 5. Let's see, 1 times 6 or 2 times 3. Which of those can add to negative 5? Well, these two can if they're both negative, which is the case in this one. Okay, we're ready for the box. Top left is our first term. Bottom right's our last term. And the negative 2x and the negative 3x go in the 2 diagonal. It doesn't matter if you switch those, it's fine. Okay, our top two boxes have 2x in common. Our bottom two have not much in common. The only number that goes into 3 and 1 nicely is 1. And since I know these both have to be negative, I'm going to draw out a negative 1. And then on the top, let's go this way. On the left, let's see, the left, 6x squared and negative 3x have 3x in common. And the only thing that's going to go into negative 2x and 1 is negative 1 again. Okay, when you get to this point, make sure the things outside multiply to give you what's on the inside. Does 2x times 3x make 6x squared? It does. Does negative 1 times 2x make negative 2x? It sure does. Yes and yes. So I'm just checking to make sure that what I factored out actually multiplies to give me what's inside. And since it does, I know I have my answer. 2x minus 1 times 3x minus 1.